Welcome to the Math Center. We're going to discuss compound interest and equivalent payments and some of the variables that are involved with those calculations. We'll do that by looking at an example. So let's get started. If we look at this question, we see that there's a $400 payment and a $500 payment. Two separate payments, probably going to have to do two separate equations. If there was three payments, we'd have to do three equations. Every time there's a payment or a change of interest rate, we're going to have to do another set of equations. Now let's look at this question. $400 was due 3 years ago, and $500 is due in 6 years. What single payment 2 years from now would be equivalent? Interest rate is 9% compounded semi-annually for the whole year. This interest rate of 9% is what we call the nominal interest rate. That'll become important in a couple minutes. We also have to realize that the question has a lot of information in it that we're going to have to dig out. Do not make the mistake of putting the 400 with the 500. All our money has to be exactly at the same time. So we're going to create a timeline. So if we look at the timeline and we decide this is now, well then for 3 years ago, we have to pay $400. And we have to pay $500 in 6 years. Now, all our money has to be paid 2 years from now. So we need to remember that it was 3 years from 400 to now, and another 2 years from now to when the money's being paid. That means that our T1 is equal to 5. We also have to realize that it was 6 years from now until we actually made the payment. But it was 2 years from now to when the equivalent payment was going to be made. Therefore, this time period here, our T2, is 4 years, because the money's only moving for 4 years. Now our two big equations are for FV and for PV. So FV is equal to PV times 1 plus I, which is the periodic interest, which I told you we would talk about in a moment. And N is the number of cycles. Notice N is the number of cycles. It's not the time. It's related, but it's not the same thing. Notice our other equation for PV is equal to FE 1 plus I to the power of negative N. It's a negative because we're going back in time. Now let's look at our two payments. The payment of 400 is moving into the future. So we're going to use a future value calculation. The payment of 500 is moving back in the past. So we're going to use our present value calculation. Now finally, we're ready to talk about the interest. We'll notice that the interest rate is 9% for the whole year, or per annum, however you want to talk about it. But it's compounded semi-annually, which means twice. So you're going to do 9% divided by how many times it happens in a year, which happens to be twice. So it's 4.5% per period. So 9% nominal interest rate. Nominal is typically the interest rate given to you in the question. And the periodic interest rate is 4.5%. We know that our PV1 is equal to 400. That's the money that has to be moved into the future. So we are looking for FV1. We know that the number of times that's compounded in a year, or M, is equal to 2. We know that our T1, or the amount of time that the money moves, has to be equal to 5. We know that our periodic interest rate is 0.045. Now this is the hidden piece of information. Our N1 is equal to our number of cycles in a year times how many years it is. So in this particular case, it's 2 times 5, which is equal to 10. So we write down our FV equation and plug the numbers in. Make sure you follow BEDMAS, so you have to do your brackets, then your exponent, and that gives us a value of $621 and 1.8776. 9, and we just round that to 621.19. If that was our final. So in the future, we have the $500, and we just have to move it back, and we don't know what it's going to be. But the value is in the past. But we know our M is 2. That doesn't change. We know that our T2, the amount of time that it travels, is 4. We know that our I is 0.045. And our N, which is that hidden piece of information, is M times T2, which in this case ends up being 2 times 4 years, which ends up being 8. So now we can just plug it into our PV formula and put in our numbers, which gives us $351.592563. But if this was our final answer, we would just round to 351.59. We're almost done. Our single equivalent payment, because all our money now is right here, is the future value, FE1 plus PV2, because all our money's at the same spot, which ends up being equal to $972.78. I hope that helped.